Hello everyone. So in this session I take a look at transforming functions. I will take this series in 3 different videos. In this first video I look at how to transform quadratic functions. It's quite easy. The basic trick here is to always compare whatsoever transformations that are given to the original parent function. What do I mean by this? The first one is the quadratic function, and the parent function is y equals x squared. So in any new transformation that you are given, if we can clearly identify that the transformation is from this parent function, then we compare this to that new transformation and speak of the changes that we can see. I'll pick a series of examples to make this concept easier. 1. Let's say I have y is 3x squared. So what transformations do we see here? I would have to compare this to the parent function y is x squared. What has been the change? The only change is this 3. What this means is all the y values will now be 3 times bigger. When the values of y becomes bigger, we say there is a vertical stretch. So in general, we have vertical stretch or shrink when we have equations of the form ax squared. If this given a is bigger than 1, we always have a vertical stretch. But if a is between 0 and 1, that is like a fraction, a proper fraction, we say we have a vertical shrink. In other words, referred to as the vertical compression. For instance, if I take example 2, y is 1/3 times x squared. So I would have to compare this to the parent function, y is x squared. What has been the change? The only new change here is that every y value becomes smaller by 1/3 or 1/3. So what is the transformation here? There is a vertical shrink of 1/3. And what is the transformation here? There is a vertical stretch of 3. I'll pick some more examples around the quadratic function, so we continue to make this concept much easier. 1 minute. So I'll still stay with the y values having a change. Let's say y is x squared plus 3. What has been the transformation? Let's compare this to the parent function, y is x squared. The only change is plus 3. What this means is we are going to move whatsoever the graph is 3 units up. So on the y-axis we can move up or we can move down, we can make bigger or we can make smaller the graph. If I have number 2, let's say y is x squared, this time let's say take away 3. What this means is we are going to shift every y value 3 units down, because the only change is here. If I compare this to y is x squared, the only change I can say is here. The only transformation is this. -3 means we are going 3 units down. So we have seen the vertical stretch, we have seen the vertical shrink or the compression, and we have just seen unit up and unit down. This is how we can transform the quadratic function around the y-axis. Let's see what happens when we have to move along the x-axis. The trick here is to see every transformation along the x-axis the opposite way. What do I mean by this? If I have y is x plus 3 all squared, if I want to compare this to the parent function, we have y is x squared. The only transformation is this, plus 3. Of course, plus 3 means we should be moving in the positive direction. But along the x-axis, we see all the transformation as the opposite. So this rather will be 3 units to the left. I'll pick some more examples. Let's say if I have this time y is x minus 3 all squared. Again, I'll compare this to the parent function y is x squared. The only change is this. So even though it is minus 3, we say we have to do 3 units to the right. So with the x, we'll always do opposite what we are seeing. Of course, there can be a horizontal stretch and also a horizontal shrink. Let's see how they look like. So if I have y is 3x all squared, and I want to check the transformations here, yes, again I have to compare this to the parent function. What has been the transformation? Just this. So again, we will do opposite whatever we are seeing. Ideally, 3 times x should be like making x values bigger, but we will say no, there is rather a horizontal shrink by this time not 3. We see 3 is same as 3 divide 1 or 3 over 1. So the opposite is to flip this. So we say 1 over 3. If I have y is, let's say, a third x all squared. Now I will say there is horizontal stretch by the opposite of 1 over 3 is just 3. So this is how we go about transforming the quadratic function. Sometimes we can also reflect them along the x and y axis. For instance, if I have, let's say, y is negative x squared. Comparing this to the parent function y is x squared, the only change is this. What this means is every y value will now be having a negative value. So if this is my coordinate plane, this is x, this is my negative x, this is y, this is negative y. So if I have all y values here positive, and now they are going to turn negative, what this means is, yes, there have been a reflection along the x-axis. I'll take one last example for the quadratic function. If I have y is negative x, this time this way all squared, negative x all squared, this means that every x value now becomes negative. So again, I can put my coordinate plane to see what is happening. If my x values are here, and then they are all going to be negatives, what that means is there have been a reflection but this time on the mirror is on the y-axis. Thank you. Do subscribe to the channel and let's continue to make maths beautiful. See you.